looking at 2.1. It's going to be dealing with graphs. Before we jump into things about graphs, just want to recall some terminology. So looking here, this horizontal line is the x-axis. This vertical line is the y-axis. Again, there's a couple names for this. Rectangular coordinate system, the xy plane, either one is fine. And this splits into 4 quadrants. Starting at the top right corner, we have quadrant 1 here. This would be quadrant 1. And then in the counterclockwise direction, we're going to count to quadrant 2. This is going to be quadrant 3. It's not going to spell it all the way. And this is quadrant 4. Now, what goes on this coordinate system? We put points. Right? They're sometimes known as an ordered pair. Oops. Sometimes we call it just a point. It looks like a dot. Or a coordinate. And it's a coordinate. And we call it an ordered pair because it always uses a value from the x-axis and a value from the y-axis. And that's how you determine that specific location. So there's some distance in the x direction, some distance in the y direction, and where they meet is how we list out the coordinate. Now, there's an infinite amount of points that are on this coordinate system. And there's some that have very specific names. For example, at the intersection of this x and y axis is where you have the coordinate 0 for x and 0 for y. And this is known as the origin, because that's where the x and y axis intersect. So 0, 0. And then we have a couple more points that with specific names. All these are still considered an ordered pair, still considered points. But let's go over some terminology. So points that are on the x-axis, and technically the origin is on the x-axis. These points are known as x-intercepts because they all have some number for the x, but they have a 0 for the y, meaning they don't go up or down at all. That's why they end up being directly on the x-axis. And similarly, points that are on the y-axis, which will technically include the origin as well. I'm sure you can guess the name. They are known as y-intercepts. And that's because they have a 0 on the x and then some number for the y. Now don't forget, the x coordinates in the first and fourth quadrant are all positive. The y's in quadrant 1 and 2 are all positive. In quadrant 2 and 3, all the x's are negative. In quadrant 3 and 4, all the y's are negative. So something to remember: positive x's, positive y's, negative x's, negative y's. Just some quick recap. And here's an example of plotting and identifying the ordered pair. Plotting just means you're going to put the ordered pair on a specific graph. Starting with the very first ordered pair, I always like to start in order. That's kind of using the name ordered pair. So I start with the x coordinate first, and I see that it's a -4, meaning I always start at the origin. I'm going to go to -4 for my first number. And then the y coordinate is +6. So that means I'm going to go up to +6. And that's where my point A is going to be. At -4, 6. And we can do the rest of them. You can pause this video, try to plot the rest of them. I'm going to go through it pretty quickly. For B, the x coordinate is a +5, so I'm going to go to the right. 5. Up to the number 5. And then I'm going to go to -3, meaning I'm going to go down to -3. And that's going to be my point B. So I did say plot and identify the ordered pair. So what do I mean by that? You can say that, I think I meant to write identify the quadrant. So I can definitely say the first ordered pair is in quadrant 2. The second ordered pair is in quadrant 4. Now let's move on to the next, where it's 4 to the right, because it's +4. But you do not go up or down at all, because that is exactly on the x-axis. So this is going to be, we said, is an x-intercept, int for short. It's not in either quadrant. It's exactly on the x-axis. My next point, starting at the origin, I'm going to go 2 to the right, and then down to -7 for the y. This is what it's going to look like here, and down to -7. And that's where my point is, which is also in quadrant 4. Lastly, we're going to be at the origin. We're not going to go left or right at all because the x is 0 for this example, but I will go all the way up to +7. And this is a y-intercept. It's not in any other quadrants. It's directly on the y-axis, so we call it the y-intercept. Now, one of the first things you do, other than plotting points on a graph, is look at a linear equation. These are the first type of equations that we graph on a coordinate system. Now, it's called a linear equation because if you look at the root word of linear, it does say line, meaning that these graphs, these equations, they make straight lines. And the way the equation looks is, this is one of the ones you might remember, y equals mx plus b, which is known as the slope-intercept form. And the reason why it has the name slope-intercept is because this very first letter, M, represents the slope, which, if you guys remember, slope is rise over run, in case we've forgotten. And that B stands for the y-intercept. But don't forget, the y-intercept is a point, meaning the x is going to be 0, and the y-coordinate is that B that you're going to see here. And we're going to use this to graph the equations in a little bit, but before we get that, I'm going to show, you can see over here, this table that we're going to use because it's going to benefit us in more than just one place. Another equation that's still a linear equation is also known as the point-slope form. Once again, it's because this y sub 1 and x sub 1 stand for the point, and again, the slope is this m that we talked about in the first equation. So it's called point-slope form. And there's also a formula that derives from the point-slope form, and it's known as the slope formula to help you find just the slope of the line. But if you notice, it does say this y sub 1, y sub 2. What does that mean? It means that you need 2 points to be able to use this formula. Now, in the other equations, you had a point for a y-intercept and a point that was given here. But for this formula, you need 2 separate ordered pairs to be able to find the slope of the line. Remember, the slope represents your rise over run. But before we get into using these, because we are going to use them, I want to talk about how to graph an equation. And this is just not for a linear equation. This is going to be for every equation we come across. This is what we're going to use to graph it. And that is going to be a table. Now, all the table is, it organizes all the ordered pairs that we're going to create to be able to graph the equation. It's going to be like connecting the dots. Because the dots, right, I just said, these dots are points. They are ordered pairs. They are coordinates. But when you put enough of those points together, it creates a pattern, and that pattern comes from an equation, and you can see the curve that that equation creates. Now, I did say for this portion, we're going to be drawing lines. Now, how does this table work? Well, I would need to, where did this 7 come from? I randomly picked a number, and this is going to be some x coordinate. So somewhere here. And this gets plugged into the equation. And you can see in a second how that's going to look. But this gets plugged into an equation. And by plugging in, it looks like this. That you kind of go, if you had the graph, you would go to your curve. And the goal is to find the corresponding y value. Or similarly, you can randomly choose some y value. You can choose any random y value. And you're plugging into your equation, and you're trying to find a corresponding x. Now, of course, this equation, or this curve, was made from an equation. And by plugging in, we'll actually have the equation to plug into. But this is how it would look like if you were doing it on a graph. You would have to start with your x, and go to your curve, and find the y that corresponds to it. Or similarly, choose a y, go to your curve, and find the x that corresponds to it. And luckily, for lines, all you need is 2 points. So let me put a little note there. only need 2 points to graph a line. So let's do an example. So looking here, right? So here's my linear equation. Now something I did skip. What makes this equation linear? If we go back, sure, there's a slope, there's a y-intercept if it's in this format, but there's all these different formats. But what makes this a linear equation? And that really has to do with the power that we see. So what do I mean by that? There's two variables here. M represents the slope, B represents the y-intercept. Those are not the variables in question. The x and the y are the variables in question. And if you notice, in each one of these formats, the x and y only have a power of 1. That's what makes an equation truly linear. The moment you alter one of these powers, it becomes a completely different equation. Even if you just change it for one of them, different equation. Change it for the other, different equation. You change it for both, it's a completely separate equation. The only time you're dealing with a linear equation, if the powers of the two variables are 1. So looking here, there's a lot of numbers going on, but if you notice, x has 1, y has 1. That's how I know this is a linear equation. And again, we will graph it another way, but I like using the table because it's going to be what we use for any type of equation. It's having a nice tool in your tool bag for whenever you come across any equation. If you forget the tips and tricks to help you graph them, you can always resort back to a table. And like I said, you have to choose either an x or y. You're going to plug it into your equation and find this corresponding variable. So here, I already have it written down. I'm going to choose an x. So every time I do an evaluation or I plug in to a variable, I always like writing it all out with the parentheses around the variable I'm replacing. So here's and then this could be any random number. It doesn't have to be anything specific. Let's say, for instance, I choose the number 4. So I'm going to plug 4 in to the equation, right? Because I'm choosing for x. That means I'm going to plug in I'm going to multiply that by 2. That's going to leave me with 8. Right, multiplying 8. Oops, sorry. It's going to give me 8 minus 3y equals 6. I'm going to subtract 8 to both sides. Right? That leaves me with negative 3y equals negative 2. And then if I divide negative 3 to both sides, my y value is going to be 2 over 3. So let me use a different color. Let me actually use black for the 4. And then the number I got as my answer is 2 over 3. So 2/3. And then remember, said for a linear equation, I need 2 points. It's just one. And just because you get a fraction as an answer does not mean it's wrong. You're not always going to have beautiful, nice answers. As long as you do everything correctly, it should work. Now, we sometimes get into the habit of always choosing x's. You don't have to always choose x's. You can choose a y value, which if you notice, I already have it set up here. I'm going to plug in 0, which that gives me 3 times 0. This cancels, leaves me with 2x is equal to 6. I can divide both sides by 2. And that's going to leave me with x equals 3. And that's all I need to be able to graph this linear equation with just 2 points. Now, if you want to try an example on your own, pause the video and try this next example. Now, let me write it out. So let's try 2 for the x. So I'm going to plug in 2 here for my x. That's going to give me, once again, 8 plus 2y equals 2. I'm going to subtract 8 on both sides to balance the equation. That's going to give me -6. I'm going to divide both sides by 2 to isolate my y value. That's going to give me -3 as my corresponding y value. And then I can choose a y value. I can plug in here to my y. It's going to be 4x plus 6 is equal to 2. I'm going to subtract by 6 on both sides. That leaves me with 4x is equal to -4. Divide both sides by 4. That leaves me with x is equal to -1. And once again, I have 2 points. I can graph this line. But before we graph it, I just want to show you multiple examples on how to use this table. Here's a nice one. Again, we can choose any points, right? I can choose 6 for the x. Plugging in 6, that's going to leave me, by subtracting the 6 over to the other side, y is going to be equal to -4. I can choose another y value, 4. And then subtracting, plugging in +4. Subtracting 4 to both sides is going to give me x is equal to -2. And there are my 2 points once again. Now what happens when you have an equation that there's only one variable attached? Well, this is saying that x is equal to -3. Now I have no y value, but it does tell me what my x needs to be. The moment I try choosing 4, that's going to make this a false statement. The moment I choose a 5 or a 0, if I choose anything other than -3, this is going to be a false statement. So that means I know that my x is going to be -3 every single time. But that means my y can be any single value. Where did I get 0 to -4? Again, y can be anything. There is no y here. We're just restricted by our x. There's no restriction on y, what y can be. And similarly, what if I have an equation where there's just a y? Same thing. This is saying that my y needs to be a 2, a 2, a 2. So any other ordered pair can be any single number. Does not matter. I'm just making these numbers up because there's no restriction on our x. The restriction is strictly on the 2. And again, I don't need 3 points to graph this line. All I needed was 2. All I needed was 2. But just to clarify a little bit. Now, let's start graphing some of these. So, these are the 2 points I got for my first graph. I'm just going to copy them so I can have them closer and more zoomed in. Now, these tally marks all represent 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 3, negative 1, negative 2, negative 3. They go by ones. So this first order pair, I have to go in the direction, x direction by 4. But this is 2/3, so it's not a whole number. And if this is 1, that means the point is going to be just shy of that 1. Because 2/3 means that if you have something in 3 pieces, you only have 2 of those 3 pieces. So if I split this space between 0 and 1 into 3 equal pieces, I am only on the second one. So my very first point is going to be at 4 and 2/3, which is going to be here. And then I have one at 3, 0, which again, I'm going to go in the x direction by 3, and I'm not going up or down at all. Meaning this point is actually an x-intercept. But like I said a second ago, once you have the 2 points, all you have to do is connect the dots. And there is your line for this equation. You plot your 2 points and draw a line between them. Let's do our next example. And at any point you can pause the video and you can try graphing it yourself. Here's the next graph. So 2 and negative 3. I'll be using the same colors. So positive 2 means 2 to the right. Negative 3 means 3 down. So my point is going to be here for the first point. The second point is negative 1, positive 3. So here, positive 1, then 1, 2, negative 1, and then up 1, 2, 3. And now all I need to do is just connect the 2 dots. All I need is 2 points to make a line. And there is my graph. Making the 2 points. Next would be this one. Copy. Paste. And I try to color code it so that we can keep track of all our points and the equations we're doing, all the examples. So the first one's going to go up to 6, but down to negative 4. That's a point here. So I went over 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4. My first point. My second point, I start at the origin. I'm going to go 2 to the left from the origin, and I'm going to go up 4 from there. That's my y value. And they're further apart, but I can still make my line. And here is the graph. And I have my graph. Now I have these last 2, which if we notice, this green one, if I graph it, for the x, I go to negative 3, but then I don't go up or down at all because it's at 0. The next point, I go left to negative 3 and then up 2. Then even if you want to graph the fourth one, you can, but I didn't need to. But if you notice, this ends up making a vertical line. And when there was only an x and that made a vertical line, what do you think is going to happen when there's only the y? Hopefully you guessed it. It's going to be a horizontal line. So x could be -3, but then y has to be 2. So same point I used before. But then the x can be +4 and the y has to be +2. Or it could be 0 and +2 as well. And we don't need that many points, but if you connect them, you would see that you end up getting a horizontal line. That's using these two. And again, a table works great. A table works really well because this is not only just for a linear equation. This could be used on a plethora of equations. You can always use a table. Now we will learn a different technique to graph linear equations quicker. But for now, using a table is great. But if you notice, all these lines, some of them, have a slightly different orientation, right? This first line has the orientation of this direction. These last two have a downward orientation, and then we have a horizontal and a vertical orientation. What determines that orientation? That is determined by the slope. Now remember, the slope formula, it needs 2 points, and luckily we have 2 points for each one of these examples. So let's try to understand the slope of these lines a little bit better. So I know for that first example, I'm going to move this onto this side because that is the points that we got. Now let's try finding the slope formula. Now we did say the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, the trickiest thing about using this is you want to make sure you keep the order correct. Because if you swap this order, it could completely change your slope. So the easiest thing to recognize is that these two come from the exact same ordered pair, and these two come from the exact same ordered pair. So I always like to set it up as I'm just going to choose this ordered pair. And like I said, the first two come from the same one. Doesn't matter which one's which. You can label them as x sub 1, y sub 1, x sub 2, y sub 2. But I'm just going to take this very first ordered pair and write them as the y above and the x below. It's going to look like this. 2/3 all over 4. And then minus. And now I want to choose the next ordered pair where the y is above and the x is below. So 0 and 3. Now what does that give me? On the numerator is going to be 2 over 3. And the denominator is going to be 4 minus 3 is going to be 1. Now you do want to be careful and recognize that this is your original fraction. And usually when you're dividing with fractions, you always multiply by the reciprocal of the denominator. But right now the denominator is just 1. So 2/3, anything divided by 1 is just going to be that number that's being divided. So this is going to give me a slope of 2 over 3. Remember, this is my rise over run. So if you look at this graph, it always, at any point that you're on the graph, you can go up 2 and then right 1, 2, 3, and you're back on your graph. Or vice versa. You can go down 2 and then left 1, 2, 3, and you always end up somewhere back on that graph. Now, of course, my sketch is a little off, but that's something to point out. And if you notice, this is a positive slope. It's a positive number. That's why the orientation, it looks like this upward hill. Versus these ones that are going downward, those are actually going to end up being negative, and we're going to see that. We're going to see that with using the formula right now. Let me just move these ordered pairs to here. Oops. I missed the negative symbol, and that's going to be important. Now, here we go with the slope formula again. Like I said, you're going to subtract these two ordered pairs from each other. So I would just write one of the ordered pairs first. So if I write the first one, it's going to be negative 3 over 2. Because this has to be from the same ordered pair. And these have to be from the same ordered pair. So that's going to be 3 over negative 1. Now, something you have to be careful with is that they are subtracting each other. What does that mean? That I have to be careful when the second number is negative. I want to make sure I include those parentheses. Don't just think it's going to be 2 minus 1. It's 2 minus negative 1 because that term, that coordinate is negative. So now if you guys remember, a negative times a negative makes a positive. And that's going to give me, in the numerator, negative 3 minus 3 is negative 6 over 2 plus 1, which is going to give us 3. It's going to be negative 6 over 3 is going to be negative 2, which we can see here. But remember, it is rise over run. So when you don't see the run and you're dealing with a whole number, you can always rewrite that number over 1, and that gives you your run. Now, if we look back at this graph, that means you can go down 2 from any point, 1, 2, and then go right 1, and you would land right at your graph. Or vice versa, you can go up 2, and then left 1, and you would be on your graph again. But like I said, that is a negative slope, and you can see the orientation of it being negative. Now, I'm not going to do this purple one. You guys can do it. Here are the points. Try it out. But once again, it is going to end up being negative. It's a different type of negative because they're clearly not the same line, but they both do have negative slopes. Now, what happens with this horizontal and vertical one? Well, those are going to be special. Let's look here. So, I'm going to set it up. So, my slope formula. If I see here, I'm going to put my 0 for my y, and then negative 3. And then the other ordered pair is going to be 2 and negative 3. Sorry, I'm going to make this a little longer. 2 and negative 3. Remember, the idea is from the same ordered pair, same ordered pair. This is 0, negative 3. This is 2, negative 3. But they have to subtract each other. Now you want to be careful with this negative, negative, because that you might want to put it in parentheses, because those two negatives become positive. And then you're going to have negative 2 in the numerator, because 0 minus 2 is negative 2. But then you're going to have negative 3 plus 3, and that's going to give you 0. And that causes a problem, because dividing by 0 does not follow the definition of division. So hence, this slope is defined. And we could have seen that coming because the slope formula tells you to subtract your x's. Well, my x's are always going to be the same because the moment I change the value of my x, this is no longer a true statement. Meaning that anytime you subtract two numbers that are exactly the same, you're always going to get 0. And this is going to be true anytime you deal with a vertical line. Because the only time to get a vertical line is when your x's are all the same. And if you try calculating the slope, if your x's are all the same, when you subtract them, you're going to get 0. So this isn't just for this example. This is actually going to happen for all vertical lines. You're going to always end up with a slope that's undefined. Now, similarly, let's look at this next example. Remember, this made a horizontal line. But once again, this told us all our y values needed to be exactly the same. And if we look at the formula tells us our y's are going to subtract each other. If they're the same number, you're going to come across 0 again. But this one's going to be a slightly different, because it's going to be 2 and then the -3 minus the 2 minus 4. Now in the denominator this time you get -7, but in the numerator you get that 0. Now when you're dividing 0 versus dividing by 0, this is just dividing it, not by it. So that means when you divide it, that does follow the definition of division. And it turns out that this is actually 0. And once again, similar to the vertical line, anytime you have a situation when your y is equal to some number, well, it's forcing that y value to always be the same and the x to be different. If the y is always the same, you're always going to get this horizontal line. But then if the y's are the same, you're always going to get this 0 in the numerator, meaning the slope is always going to be 0. So, something to note, maybe I should note this here. Make a quick note on the side. The equation of all vertical lines is x equals some number and a slope that is undefined. So you want to remember that. We're going to use this idea again in later on when we talk about rational functions, because rational functions are going to come across this idea of getting 0 in your denominator. And then we'll talk about how that looks, and knowing that when x gives you a constant, you're dealing with a vertical line. And similarly, if I make a note here, the equation of all horizontal lines is y equals some constant, and what did I say? And with a slope of 0. That's also going to be important when we look at other equations that are not going to be linear later on. To not make this video too long, I will then discuss another method of graphing linear equations. But for now, This is a method that uses a table.